transverse wave. The same like the previous concept, let us try to understand the transverse waves. This is all about your transverse waves. Let us suppose that a wave is being transmitted from one point to another point represented with this horizontal wave line. All the particles of the medium, so these are the particles of the medium. So whenever a longitudinal wave travels through a medium, whenever a transverse wave travels through a medium, we observe that all the particles of the wave starts vibrating up and down. Something like this, up and we observe that whenever a wave transfers from, let us suppose from left to right, all the particles of the medium start oscillating or vibrating up and down. That means perpendicular to the direction of propagation of the wave. Okay, so if you suppose that the particles are traveling along the x-axis, all the particles of the medium start vibrating in the perpendicular axis, that is along the y-axis. Okay, so all the particles will start vibrating up and down, perpendicular to the direction of propagation of the waves. Okay, children. So, whenever a wave propagates in this medium, if the particles of the medium vibrate perpendicular to the direction of the propagation of the wave, that is up and down mode, then they are called as your, generally termed as your transverse waves. And what type of waves comes under this transverse waves means, examples for this transverse waves are waves on the surface of water, generally comes under this category. Waves on the surface of water. So these are the examples for a transverse wave. So what are the examples, children? So whenever you observe that the particles of the water surface, whenever some disturbance is created, like the previous example what I have considered you regarding whenever a stone is thrown into a pond of water, the particles of the medium start vibrating up and down and the disturbance in the form of energy is transmitted from the point of the disturbance to the other places. So, all the waves that are produced on the surface of the water are transverse waves. Not only things, children. So, waves produced in a stretched rubber band, up and down motion if you observe, or whenever a wave is produced in the case of a stretched string or a rubber band also, transverse waves are produced in this. On all the electromagnetic waves like light waves, radio waves, microwaves, x-rays, whatever you consider are also comes under this transverse waves. So that means all the particles of the medium vibrate up and down. So if you would like to have graphical representation of the wave. So this is the wave propagation if you consider. Let this be x-axis and here this be some y-axis. Let me represent the same. This OX, OY and OY dash. So the wave must be traveling something like this. Okay. Here all the particles above this medium, okay, is called as your crests. These are called as your crests. And the below one is called as your troughs. Crests and troughs. Okay, so the elevation or the hump-like structure, whatever you observe, these are called as your crests, and the depression or the trough-like structure, whatever you consider, okay, these are called as your troughs. And whenever a transverse wave propagates, we always observe that an alternate crest, trough, crest, trough, crest. So, an alternate crest and troughs are being formed. And the distance between any two crests or any two troughs is equals to wavelength. Alternate, the distance between any two wavelengths or any two troughs is called as your wavelength, indicated with the letter lambda. Okay, children. So similarly, let us also think about, and also remember that the distance between a crest and a trough is equals to lambda by 2. Between a crest and a crest is lambda, and between a crest and a trough, half part of that is called, given as your lambda by 2. Okay, and remember that children, these transverse waves cannot travel inside the liquids as well as gases. Transverse waves cannot travel through liquids or as well as gases. Okay, so now let us also look into it in detail. Example for this is the case of a helical spring. So this is a spring, let us consider that, or a stretched rubber band, stretched string, whatever you consider. When the spring or string is being disturbed up and down, up and down, up and down continuously, then the shape of the spring would be observed something like this. The spring would have taken this form. Okay, so here we observe that the upper layers are called as your crest, whereas the bottom layers are called as your troughs. Okay, whenever a stretched spring or a stretched rubber band, whenever, or a stretched spring, whenever it is vibrated up and down continuously, the wave will be, some cases you can say that large elevation is there, and other cases some sort of depressions is there. So that hump-like structure is called as your crest, and the curved-like structure, the below case, is called as your trough. So alternatively, a crest and a trough is being formed. And remember always that the distance between any two crests or any two troughs is always equals to a wavelength given by lambda by 2, and the distance between a crest and a trough is always given as lambda by, distance between any two crests or troughs is given as, called as a wavelength, indicated with the letter lambda, and the distance between a crest and a trough, alternate crest and a trough, is taken as a half of the wavelength, that is lambda by 2. Okay, children.